Alright, in this video we're going to also build a hyperbola, uh, basically toward the purpose of locating a ship or beginning to locate a ship. So here's the scenario. We have station B is located 400 miles due east of station A. So let's just up here in the corner, let's just get kind of a reference here. This is the north, west, east is how we'll look at things. This says station B is located 400 miles due east of station A on a coastline. So let's draw what will constitute a coastline here. Okay, I think that'll be out of the way. And so we've got station A, we'll put station A here. Okay, and station B. And of course, we know that, hey, it's 400 miles, so we're dealing, that's our units here. Okay, between them. And so, okay, so if we're going to start building things, again, it comes back to that thing. Here's our situation. Here's what we have. Here's our figure, our picture, if you will. Now I put my plane on there, my XY axis, as I want. And so what I'm going to do, and yes, I know a close line is not going to be straight, but I can draw a straight line between the two stations, and that's going to be my x-axis. And so, of course, it only makes sense then, in this particular case, if I take and put my y-axis right down through the midpoint between those two, whether that looks like the midpoint or not. And so then that means that then I will locate on the xy plane then, I will locate my foci A and B at minus 200, 0, and at 200, 0. Okay? And then it says a ship received a signal from B. So we've got a ship up here somewhere. Now let's read this and see kind of where roughly we're going to put it on our picture then on our plane. It says the ship received a signal from B 1200 microseconds before it received a signal from A. So that tells me right there, the big thing I want to, that was as far as my picture, is that my ship is closer to B. And I'm going to label this a point P, but it's my ship. Okay? All right, but then I have a reference point. So, okay, so now that uses, now think about it, then that's telling us that there's a difference between when B received a signal and when A received a signal. And that's what's leading us to, oh, a hyperbola. Okay? And so we start putting this together. It says the ship, of course, we don't have distances. We don't know this distance. If we knew that, that'd be great. But we do know, we kind of know the distance. We know it in the fact that, hey, ship received a signal from B 1200 microseconds before it received a signal from A. So if you recall, everything we built up, eventually we're going to want to, we're going to build a hyperbola. Okay, it's going to have kind of a form here, x squared over a squared minus y squared over b squared equal to 1. And the only thing we know right now is c, because we've located our foci, so we know that c is 200, and of course that's 200 miles, just to make sure we remember. Okay, we need to find a and b. But if you remember, when we built up the equation for our hyperbola, we established that this, hyperbola is built because the difference, the difference. So in other words, this, if you remember right, PA, kind of referencing our picture here, minus PB is equal to 2A. And that's what we established, is that 2A was that constant difference. Okay. Well, in our case, that constant difference, 2A, we don't know what PA and PB is, but we know that the constant difference is the fact that, hey, it received a signal from B 1200 microseconds before it received it from A, and then we're going to assume that a radio signal travels at a speed of 980 feet per microsecond. So 2a, this constant distance would be, okay, the difference is one received at 1200 microseconds before the other one, and sound or radio signal travels at 980 feet per microsecond. So that tells me that 2a is, this is in feet right here, don't forget. So 2a in feet is 1,176,000 feet, which is simply 2450. I'm trying to keep things as exact for as long as I can. 2450 over 11 miles, which this is of course approximately, if you want, 222.73 miles. Okay, that's 2a. So that tells me that, hey, a is 1225 over 11 miles, of course. And then, of course, now I can put together, if you recall, so I have C, I have A, and so if you recall, C squared is equal to A squared plus B squared when we're dealing with a hyperbola. Or for us, what we want to do is actually, hey, think of it this way, because the B is what we don't have now, but we have everything. So B squared is equal to C squared minus A squared. So that's going to be, C is 200, A is 1225 over 11 squared. So we get that B squared is equal to, this is B squared, so it's a big number, 3,339,375 over 121, 11 squared. Okay, so now we have everything, and this is our general equation. We know what A is, we know what B is now, and so then this tells me the ship is located, we don't know exact location, but the ship is located on a hyperbola. If we're referencing the plane we put together, the XY plane, then it's located on this hyperbola. And of course, this big number I'm writing down here in the denominator is nothing more than just A squared. Minus then y squared over B squared, which is 3,339,375 over 121. So we're on that particular hyperbola. Now, just to get a nice picture of the hyperbola, then we'll do what we've done before. Go to GeoGebra, and there we have it. So you can see the equation up here, and actually I'll just click on it. There you can see there's my equation. I've rearranged things, so I've got 121x squared over that roughly 1.5 million, and minus the 121 y squared over the little more than 3.3 million. Okay, and so there's the equation. Once again, you know, we know just from things that, well, if above the x-axis, if you will, or our coastline, if our ship is out to the north or northeast, northwest of our two, then it's up here somewhere. That's the way we drew our picture. Of course, it could be down here on this, but nevertheless, it's on this branch, either down here south, southwest, southeast of the two foci, if that's where the water is, or if the coastline, and then we're up here north. So that's the most we know right now. Next video we'll look at what we need to do to pinpoint things.